Hi there, thanks for joining us today. We are looking for a junior Angular developer to join our team, and based on your resume, you have about a year of professional experience. I want to keep this conversation natural, so we will just dive into some technical topics and see how you think about the framework. To start off, could you just tell me a bit about how you typically get started with a new feature? For example, if I asked you to create a new component for a user profile page, how would you actually do that using the tools available? Sure, I would be happy to. For a new component, I almost always use the Angular CLI because it is just much faster and ensures the file structure is consistent. I would open my terminal in the project folder and run the command ngGenerate component followed by the name of the component, like profile user. What I like about this is that it does not just create one file. It automatically generates the 4 necessary files for me. You get the TypeScript class for the logic, the HTML file for the layout, the CSS file for the styling, and a testing file for the unit tests. Also, if I am not using standalone components, the CLI automatically registers the component in the appropriate module, so I can start using it in my templates immediately without having to manually import and declare it. That is the standard workflow, and it is definitely the way to go. Now, once you have that component, you need to get data onto the screen. I want to talk about data binding. In your experience, when would you choose to use interpolation, like the double curly braces, versus using property binding with the square brackets? Right, so those are the 2 most common ways to get data from the TypeScript class into the HTML. Interpolation is basically for displaying data as text. If I have a variable called username and I want it to appear inside a paragraph tag, I use double curly braces. Angular takes that variable and converts it into a string to put it between the tags. Property binding is different because it is used to set the value of a specific property of an HTML element or an Angular component. For example, if I want to bind a Boolean variable to the disabled property of a button, or a string to the src attribute of an image, I use the square brackets. The big advantage of property binding is that it allows you to pass non-string values, like Booleans or objects, directly to the property without them being forced into a string format first. That is a good distinction. Now, moving in the opposite direction, we have event binding. If property binding is about sending data from the logic to the view, what is the role of event binding, and how do they contrast in terms of data flow? Exactly. If property binding is a one-way street flowing from the TypeScript code to the HTML, then event binding is the street going back the other way. I use event binding when I want to send a signal from the HTML template back to the TypeScript code. Usually, this is triggered by a user interaction, like clicking a button or typing in a field. I use parentheses around the event name, like click, and then I call a function defined in my component class. So, in short, property binding is for setting values and updating the view, while event binding is for listening to actions and triggering logic. Let's dive into forms for a bit, since you will be doing a lot of that. You mentioned the Angular CLI and basic binding, but for user input, we have different modules. Can you explain what the Forms module is, and specifically what ngModel does within that context? The Forms module is a built-in module that gives us the tools to handle user input. The core of it is ngModel. I use ngModel to create 2-way data binding between a form element and a variable in the component class. The way it works is that if a user types something into an input field, the variable in my TypeScript code updates automatically. At the same time, if I change that variable programmatically in the code, the input field on the screen updates instantly. It is really helpful because it keeps the UI and the data in sync without me having to write a bunch of manual event listeners to capture every keystroke. 2-way binding is convenient But as projects grow, we often move toward reactive forms. From a conceptual standpoint, what is the difference between template-driven forms and reactive forms? Which one would you choose for a complex form with a lot of validation? The main difference is really about where the logic lives. Template-driven forms are very similar to how things worked in the older AngularJS. Most of the logic is handled right in the HTML template using directives like ngModel to track changes. They are great for very simple forms because they are quick to set up, but they can become a nightmare to test because the logic is so tightly coupled to the view. Reactive forms, on the other hand, move all that logic into the TypeScript component class. Instead of relying on the template, I explicitly create form control objects and group them together in a form group. This gives me way more control. If I have a complex form with dynamic validation or needs to track the value of a field in real time, I would definitely choose reactive forms. It also makes unit testing much easier because the form structure and validation logic are independent of the HTML layout. Speaking of logic, let's talk about where that logic resides globally. You use services in Angular quite a bit. For someone with your experience, how do you describe a service to someone who is not familiar with the framework, and why not just put everything in the component? I would describe a service as a special class that holds business logic, data, or functions that need to be shared across multiple components. If I put all my logic in a component, that component becomes bloated and hard to maintain. Plus, if I need the same logic in 3 different components, I would have to duplicate the code, which is a bad practice. By putting the logic in a service, I keep my components lean. The component stays focused on how the page looks and behaves, while the service handles the heavy lifting, like fetching data from a server or managing user authentication. It basically separates the presentation layer from the data management layer. That brings up a very important topic, dependency injection. Can you explain what dependency injection is in the context of Angular, and how a component actually gets access to a service? Dependency injection, or DI, is a design pattern where a class requests the objects it needs from an external source instead of creating them itself. In plain JavaScript, I might use the new keyword to create an instance of a class, but in Angular, I don't do that. Instead, the component asks for the service in its constructor. When the component is instantiated, Angular's built-in injector looks at the constructor, finds the required service, and provides it. This makes the code much more modular and easier to test, because I can easily swap out a real service for a mock service during testing. It also ensures that multiple components can share the same instance of a service, which is key for keeping data in sync. You mentioned the injector. I want to dig deeper into the providers. When you define a service, you often see providedIn, root. What does that actually mean, and how does it differ from providing a service at the module level or using providedIn, any? This is something I had to spend some time learning. When I use providedIn, root, I am telling Angular that the service should be a singleton. This means there is only one single instance of that service shared across the entire application, regardless of which component or module needs it. Another big plus is that root services are tree-shakeable, meaning if the app grows and I stop using that service, the compiler is smart enough to remove it from the final production bundle to save space. If I provide a service at the module level by adding it to the provider's array of an ngModule, it is available to everything in that module and its children, but it isn't necessarily global in the same way. Then there is providedIn, any. This one is interesting because Angular creates a new instance of the service for every lazy-loaded module that injects it. However, it still shares one instance among all the eager-loaded modules. It is a middle ground that allows me to have separate states for different parts of the app without making the service completely private to just one component. Great explanation. Let's shift gears to the DOM and how Angular handles the view. I want to ask about structural directives. Specifically, can you explain ngIf and the difference between using it versus using the hidden property? Sure. ngIf is a structural directive used to conditionally show or hide an element based on a true or false value. The key thing about ngIf is that it physically adds or removes the element from the DOM. If the condition is false, the element is completely gone. This means its component lifecycle hooks are destroyed, and it consumes no memory in the browser. The hidden property is different. It is a property binding that just toggles the CSS display property. The element stays in the DOM, it remains initialized, and its lifecycle hooks are still active. It is just not visible to the user. In terms of when to use which, I would use ngIf for better performance when the content does not change very often, or for security reasons where I don't want the element to exist at all if the user isn't authorized. But if I need to toggle the visibility of something very quickly and frequently, like a drop-down menu that opens and closes a lot, I would use hidden so that Angular doesn't have to keep re-rendering the element from scratch. Since you mentioned lifecycle hooks, let's talk about those. How does Angular manage the lifecycle of a component? And why would you use a hook like ngOnInit or ngOnDestroy? Angular manages the lifecycle through a series of hooks, which are basically special methods that the framework calls automatically at specific moments. It starts when the component is created and ends when it is removed. I use ngOnInit for the initial setup. I avoid putting heavy logic in the constructor because the constructor should just be for simple dependency injection. In ngOnInit, I usually put my API calls or initialize variables that depend on input properties. Then there is ngOnDestroy. This is crucial for preventing memory leaks. If I have a timer running or a subscription to an observable, I need to clean those up in ngOnDestroy. If I don't, the subscription might keep running even after the component is gone from the screen, which can slow down the app or cause weird bugs. That's a very common mistake for beginners, so it's good that you're aware of it. Let's talk about communication. Imagine you have component A and component B. They are siblings, meaning they share the same parent but aren't parent and child to each other. How do you get them to share data? Since they are siblings, they can't talk directly. The recommended architectural approach here is to use a shared service as a middleman. Component A doesn't send data to component B. Instead, it sends the data to the service. To make this work in real time, the service usually uses a behavior subject or an observable. Component B then subscribes to that observable in the service. This way, as soon as component A pushes an update to the service broadcasts that update, and component B receives it immediately. This keeps the data synchronized without the components needing to know about each other's existence. That's the correct pattern. Now, let's push that a bit further. Suppose you have two different services that both need to fetch data from the same remote API endpoint. If both services just call the API independently, you're making unnecessary network requests. How would you optimize this to handle caching and efficiency? To solve that, I would create a dedicated data access service that acts as the single source of truth for that specific API. Instead of the two business services calling the API directly, they both inject this shared data service. Inside that shared data service, I would use an RxJS operator like shareReplay or a behavior subject. When the first service requests the data service fetches it from the API and stores the result in a stream. When the second service asks for the same data, the data service doesn't go back to the network. It just provides the cached value from that stream. This ensures the API is called only once, and all dependent services are using the exact same set of data. I like that you mentioned Share Replay. Let's talk about the module system. We have the ngModel decorator. What is its primary purpose? And I've noticed in more recent versions of Angular, things are changing with standalone components. How does that affect the role of ngModules? The primary purpose of the ngModel decorator is to organize the app into cohesive blocks of functionality. It's like a container that tells Angular which components, directives, and pipes belong together, and which other modules are needed to make them work. Before version 14, every single component had to be declared in a module, otherwise, the framework wouldn't recognize it. Standalone components changed this significantly. Now, a component can manage its own dependencies directly in its own decorator. This makes ngModules optional for many use cases. It really reduces the amount of boilerplate code and makes the app structure flatter and easier to understand, especially for smaller components that don't need to be part of a larger grouped module. Let's go back to the DOM for a second. Sometimes when debugging in the browser, you see these attributes in the HTML that start with ngReflect. What are those? And how do they differ from structural directives? Oh, those can be confusing at first. ngReflect attributes aren't actually functional parts of the Angular framework. They are just debug helpers that Angular adds in development mode. They basically show you what the current value of a property is so you can peek at it in the DOM inspector. When you build the app for production, those attributes are completely removed and have zero effect on how the app behaves. Structural directives are completely different. They are actual tools that change the layout of the DOM by adding, removing, or replacing elements. You can tell they are structural directives because they always have an asterisk before their name, like asterisk ngIf or ngFor. They are essential for the application logic, whereas reflect attributes are just for the developers during testing. Good. Now, let's talk about security and routing. When would you implement a root guard, like canActivate? And can you give me a few real-world examples of how you've used them or would use them? I use a root guard when I want to prevent a user from accessing a specific page based on certain conditions. It's basically a security checkpoint that runs before the component is even loaded into the DOM. The most common example is authentication. If I have a private dashboard, I don't want an unauthenticated user to be able to just type the URL and see the page. The guard checks if the user is logged in. If they aren't, it redirects them to the login page. I could also use them for permission levels. For instance, only an admin user should be able to access a settings or user management page. Another useful case is using a guard to warn a user if they have unsaved changes in a form before they navigate away from the page, so they don't accidentally lose their work. Let's wrap up the technical part with testing. Testing services can be tricky, especially when they depend on external HTTP endpoints. If you have a complex service, how do you ensure your tests are isolated and fast without actually hitting a real server? To do that, I use the HTTP client testing module provided by Angular. It allows me to replace the actual HTTP backend with a mock system, so I'm not making real network calls. I use the HTTP testing controller to intercept the requests that the service is trying to make, and then provide fake responses. This makes the tests isolated because I don't have to worry about network stability, server downtime, or the data on the server changing. It also makes the tests run incredibly fast. When I write these tests, I focus on different scenarios. I'll trigger a successful 200 OK response to see if the data is processed correctly, but I'll also trigger a 404 or 500 error to make sure the service handles API failures gracefully without crashing. The app. That's a very solid approach to testing. We've covered a lot of ground here. Before we finish, is there anything specific you've been learning lately in the Angular ecosystem, or any challenges you've faced recently that you're proud of solving? Lately, I have been diving deeper into RxJS. I found that as the apps get more complex, just using simple observables isn't enough, and I've been learning more about operators like switchmap and combine latest to handle multiple data streams more effectively. One challenge I recently solved was with a very large form that was lagging when the user typed. I realized I was triggering too many change detection cycles because of how I was handling input events. I managed to optimize it by switching to a reactive approach and using the debounce-time operator to only trigger the logic after the user stopped typing for a few hundred milliseconds. It made the UI feel much smoother. That is a great, practical example of improving performance. I appreciate you sharing that. Well, that covers everything I wanted to go over today. I think you have a very good grasp of the fundamentals for your level of experience, and you're thinking about the right things regarding architecture and performance. Thank you for your time, and we will get back to you soon regarding the next steps. Thank you very much for the opportunity. I really enjoyed the conversation. I look forward to hearing from you.